Assalamualaikum and good day to all participants. I'm Dr. Nik Raihan Yusof. I would like to share my research on the effect of heavy metal ion on the photodegradation of commercial formulation of glyphosate. So why we need to study on the effect of heavy metal? Will heavy metal give beneficial effect to the photodegradation process? So actually, there are many possible methods that can be used, including biological degradation, adsorption, solar radiation, ozonation, and treatment with advanced oxidation process. However, this efficiency of all those methods is reduced in the presence of heavy metal ion. This observation is particularly true if the organic species forms strong complexes with the metal ion in the solution. So this is the structure of the organophosphate compound, which is glyphosate, under a type of herbicide. It contains three functional groups: carboxylate, amino, and also phosphonate group. And this is photoreactor. It's divided into three parts, which is the lamp, UV lamp, 400 watt, emission well, where there is a tube for cooling water in and out, the reaction chamber with capacity 400 ml, and the irradiation took about 5 hours. Alright, the characterization used is UV visible spectrophotometer to monitor the depletion peak of the parent compound. It's also supported with the HPLC in order to determine the degradation, the concentration that have been degraded in that solution. The observation, the monitoring of the heavy metal concentration be monitored using FAAS with this setting. The intermediate produced throughout the photodegradation is being detected by ion chromatography. Okay. Based on the effect of single metal ion, the result shows that the addition of 5 mg per liter of single metal ion Fe2 significantly increased the degradation efficiency of glyphosate from 22.3% to 82.2%. However, when the concentration of Fe2 ion was increased to 15 mg per liter, the percentage degradation reduced to 66.4%. Nevertheless, the value was still higher than the value of the photodegradation of glyphosate in the absence of Fe2 ion. This increment is due to the presence of Fe2 ion being oxidized to Fe3 plus and reduced back to Fe2 plus in the consumption of electron. The formation of this of iron 3 hydroxyl aqua complex can lead to the formation of hydroxyl radical by photolysis process. Hence, the increase in the degradation is attributed to the cyclic reaction in which iron can easily be reduced and oxidized in aqueous solution containing free electron. Moreover, the production of FeOH2 plus complex has the ability to capture the photogenerated electron. Thus, it's preventing the recombination process of hydroxyl radical with a free electron, and eventually yielding a reduced form of FeOH plus complex. The synergistic combination of this reaction explains the enhancement of the photodegradation efficiency of glyphosate in the presence of Fe2 ion. However, when the concentration of Fe2 ion was increased from 5 to 15 mg per liter in the solution, the degradation was slightly decreased to 66.4% only. This happened because the hydroxyl radical may be scavenged by a reaction involving a high concentration of Fe2 plus in the solution. However, the effect of copper-2 ion, the single copper-2 ion, has slightly reduced the efficiency of degradation of glyphosate, and further reduction was observed when the concentration increased from 5 to 15 mg per liter, giving only 16.4% of the percentage degradation. This is due to the formation of complexes between copper-2 ion with the glyphosate complexes, and this be likely to be contributing factor for the reduction process. Moreover, The incompleted d orbital of copper-2 ion are capable of forming at least 3 types of coordinated complexes, where the geometry of these complexes could be tetrahedral, square planar, or octahedral. However, these complexes with glyphosate is octahedral type. However, no precipitation occurred in the glyphosate solution after 5-hour irradiation, indicating the soluble copper-2 glyphosate complexes were formed. Further explanation is that in the presence of UV light, copper-2 ion is behave as electron scavenger that thus reduced to Cu+ and oxidized back to Cu2+ by consuming hydroxyl radical. Due to this cyclic reaction, there is a reduction in the overall concentration of hydroxyl radical and ultimately decreases the concentration of hydroxyl radical in the system and retarded the degradation efficiency. For zinc, the addition of zinc shows only a slight increment in the photodegradation of glyphosate. However, it was noticed that degradation slightly dropped to 24.7 when the concentration of zinc 2 is increased from 5 to 15 mg per liter. Nevertheless, there is no significant effect of 5 or 15 mg per liter on the photodegradation of glyphosate. It can be seen that the presence with single copper metal significantly inhibited the photodegradation of glyphosate. So as in our real world, that is impossible to have only one single metal. It's mostly like a cocktail, the mixed one. Hence, a model solution containing all mixed metal ion was prepared to simulate a real wastewater and then tested for the photodegradation. The result clearly show that the positive effect of the addition single Fe2 ion alone just now is no more effective this time in the mixed metal solution. So to overcome this, we try to treat this mixed metal ion with addition of the hydrogen peroxide 30 mg per liter. It shows that in the single one, it increased the degradation from 20% to 36.5%, showing the increment. However, for the mixed one, once the mixed metal ion treated with the hydrogen peroxide, only a very slight increment, but it is not significant. So this is believed that it's mainly due to the formation of copper glyphosate complexes. So it's clearly show the dominant behavior of copper-2 ion in retarding the degradation efficiency in the glyphosate degradation. Throughout photodegradation, intermediate species is produced. So if you still remember, the structure of glyphosate is like this. So from this structure, when it's been degraded, it's contribute to the phosphate and nitrate anion. Okay. However, in this study, the detection of the phosphate and nitrate anion concentration is very low compared to the theoretical value. This is because the evaporation of nitrogen gas may occur, and this being supported by the previous study Manacero and Fu, where they also detect the low concentration of phosphate and nitrate. So in this study, we concluded that the effect of single and mixed metal ion, in the single one, copper significantly inhibited the degradation process. But in the mixed one, the presence of mixed metal ion retarded the degradation of glyphosate. The addition of hydrogen peroxide to the solution containing just copper ion alone increased the degradation, whereas the presence of mixed metal ion, no significant increase in the degradation efficiency of glyphosate was observed. So that's all from me. Thank you very much.